Du lytter til Den Grønne Sofa, en original podcast fra Nios. Welcome to another episode of The Green Sofa. Mia, we have a very special guest. Can you help us understand who we have in the green sofa?
Yes, welcome Olivier Corradi. You are the founder of Electricity Maps, which was a startup, but maybe still is a startup that we will talk about today. And we are also talking in English. And it's not because, Olivier, you actually speak Danish as well, and French. But you said you would be most comfortable in English. And also Electricity Maps clients or audience is also probably very international. So that's why we are talking in English today. And welcome.
Thank you.
Let's start with the Electricity Maps. What is Electricity Maps?
Good question. So Electricity Maps, in a nutshell, our goal is to decarbonize electricity. And the way we want to do it is by informing both people and devices in order for them to make better decisions. And if we go a step further into what that actually means, is that we want to make sure that every time there's a device that needs to make a decision about when to consume electricity, it knows that it can consume electricity at the time where it will help the grid the most. And because we want to decarbonize electricity, is the time where electricity has the least carbon emissions. Something else we're doing as well is, I mentioned we want to help people make better decisions. And here there's basically two groups we're looking at. One are the citizens. We want to make sure that, they are becoming more informed, then they can vote for better politicians, and that will drive the world in a better direction. And the last thing that we're looking at are policymakers, because when we're looking at intelligent policymaking, it needs to be data-driven. And so with the kind of data that we're collecting, we're also helping inform the policymakers on future decisions. And we might get back to that a little bit later.
Cool. I have known you for quite a while. And for me, you're I would not say famous, but you're known for this. It is actually an electricity map. So you have the world map, where you can see all the different nations, and they are colored according to how green the electricity mix. And you can actually click on the countries, and then you can see the different sources. Is it wind power? Is it solar energy? What is driving? Is it coal? What is it driving? And then you can see the interactions between the different countries. So I think it's pretty amazing and pretty fun. And maybe I'm biased because I'm an engineer. I don't know about you, Jens. What do you think?
No, I was actually also pretty impressed. It's very elegantly put, and it's you haven't paid us to say this. And I've actually showed it to family and friends, and they are. Most of them are like, "Oh, what was that? Can you forward me that link?" So kudos to whoever takes care of your user experience or user interface. It's very easy to understand, and the scale. Maybe it's not so easy to understand if you're colorblind. You even have a colorblind mode, right?
We do have a colorblind mode now, which was requested quite heavily by the community in the early days. And again, because one of our core beliefs is that we need to make this information accessible, widely accessible. Then this includes also being able to have color scales that are inclusive, so you can understand really the nuances.
Oh, that's cool.
And about the color scale, so we have dark green, which is the best, and then we have dark brown, which is, there is the most room for improvement, or how we should put it, right?
That's a good way to say it. So the scale represents what we call carbon intensity.
Yes.
Technically speaking, it is gram of CO2 equivalent per kilowatt hour. But what that means in sort of more intuitive terms is when you're consuming 1 unit of electricity from your power plug, how much CO2 is going to be emitted in the atmosphere based on that particular kilowatt hour or unit of electricity. And this takes into account not only CO2, it also takes into account other greenhouse gases. And this is where the equivalent part of CO2 equivalent comes in. But we actually also look at the whole life cycle. For example, if you are installing a wind turbine, you might have offshore, you might have ships that are running on fossil fuels to install it. And so we're not doing all these calculations ourselves, but we are relying on the IPCC and other global studies that have been very trusted, very validated, in order to be able to say in the end, okay, if I, on average, consume some electricity right now, what am I responsible for?
And it is, maybe it's a bit nerdy, but I looked into whether there would be difference in your solar energy depending on where you are in the world. And you actually do have that. So if you are closer to south of Europe, maybe, the impact per kilowatt hour produced with a solar panel is lower than in the Nordics, for example. And I think that's pretty cool, because I thought I was, I would find a mistake, and I didn't. But I thought that was pretty cool, because there are, of course, more hours with sun in some places.
So exactly. You have the fixed cost of the panel manufacturing, which are spread out over different amount of hours. And so if you consume 1 kilowatt hour from the same solar panel in different places, because the lifetime is a little bit different, if you are in the Nordics or if you are in Spain, for example, then indeed you will have different numbers.
Yeah, that's pretty cool.
So it is called electricity maps, and when you enter the website, there is the entire world is represented, but the entire world is not colored. And I can imagine that it was sort of like having a map, and then it got populated along the way. And you also mentioned the community. So can you talk a little bit about how were you able to actually populate or color the world?
So this actually brings me back to the absolute first, let's say, the inception of electricity maps itself. The question I had at the time, and maybe we'll get back to that, is I was seeing all these news headlines that were saying now Denmark has run on 100% wind, Portugal has run on 100% renewable for a couple of hours. And the question I had was really, okay, how true is that? And for how long, how often does this happen during the year? How far are we from a system that runs on 100% renewable every hour of the year? And so I created this visualization a little bit like a side project, open sourced it, put it online, showed it to colleagues, friends, researchers, and then it started having a little bit more attention. And we started having some community, a community that started building up with some folks who said, I know where there's data for another country, can I help you put it on the map? And little by little, the focus on the development was more about building the tools to enable the community to contribute more than me building, every country and adding it to the map, because I knew for certain that I could never be able to add all the countries on the map. And so there was a lot of time spent on the infrastructure itself, but very quickly we had students visiting the map and saying, hey, I actually know where there's data. And so they would open up an issue on GitHub where they said, I know where the data is, but I have no coding skills, for example, so I can't add them. On the other hand, you had some computer science students that would come on the website and say, how can I help? And I would just point them at the GitHub issues that said, here's the data, and then they would go and implement it. And once you've built a product out in such a way that these two groups discover each other, then you have almost like a flywheel that turns by itself. So I remember a contributor in the very early days who mentioned that it was like taking a paintbrush and painting over all these different countries, because you arrive on an electricity map, it was completely gray because we had no data for a lot of countries. And so as soon as you added a new country, it was like taking this paintbrush and filling in the, coloring the map suddenly. So that was quite of a cool and exciting period of time.
So you explained that that doing electricity maps, at least for you, in the beginning was actually painting yourself, but more and more became, facilitating a workshop where a lot of painters could take part in doing this wonderful picture. Dare I ask, what did you do with the incentives, or did all these contributors just, it was because this was non-profit, or, why did they bother?
Yeah, I was also thinking, what's the business model? How do you earn money on this?
We'll get to the business model after, but I think mostly first, let's dive a little bit into the question of what is driving a community contributor to actually contribute. And I think you have multiple categories. You have the activists who know about something, they have an intuition, and they want the instrument, they want to be equipped with the tool to be able to yell at other people, to put it in a very direct way. And so they will be interested in coming to Electricity Map and saying, my country is not there, I need that country to be there, because then I can actually create the awareness that I need in order to create the change that I want. That's one type of contributions we had. Then you also have, mostly in the tech space, a lot of, let's say, very competent folks that have a little bit of time left on the side. They want to do good. They might be working, on the very big tech companies like the Googles, the Microsoft, but still want to do something for the climate. And when they saw our project and saw the open source, they immediately say, hey, you know what? I want to do something nice. How can I help? And if you have something that's well packaged, where you say, this is how you can help, and this is how easy it is to help, then they will help. And these are the two main use cases that we had, I would say, in terms of contributions.
I think it's so cool when you're able to, because everybody dream about running a community where everyone is just supporting, and if it's important enough for them, they'll work, around the clock to fix the issue. But it's maybe it's not that rarely, but it's rare. I don't see it too often, and maybe it's because I'm too much involved in the business world and not enough in a world where you do something for a cause that's not 100% related to earning money.
I mean, I will say we tried as much as possible to treat contributions almost as a step in the conversion channel, like in the sense that you arrive on the website, we want to have a very clear call to action for contributors, with a link that says, if you see any issues, raise them here. If you know how to code, click here, and then when they click here, they need to, and they arrive at a place where someone has said, there's data for this new country. We, right after, need to be ready with the documentation that explains to someone, this is how simple it is to contribute. And at the time, it was just make a Python script. Here's the format of the data you need to get back. And if you make a script that can generate that data, that's good enough. Then we'll take that contribution and it will work. And have that level of simplicity means that, the step you have to go through in order to contribute was quite simple. And we had multiple different types of contributions as well. I remember one of the early contributors created a whole translation system for the app. Again, they wanted the app to be in their own language. Didn't exist. So they said, you know what, let's translate the map or let's build a translation system, which opened up a new area of contributions because we could have native speakers in other languages come in and then readjust some of the translations. And we have now, translations in Chinese and so on. In the beginning, we just Google translated stuff. But after a while, people would come to us and say, this is actually not the right translation. I would like to change it. And that becomes a contributor, right? So always treat it as a conversion channel and optimize for that. Then you make it simpler for people to contribute. I think that was a key reason that it worked.
And then I see this open source community, and I guess unlike you, Jens, I think it's pretty common at least within software. It's very common that you share. But what's your business model? How do you earn money on this? I think it's brilliant, and I really love it. But how do you earn money on it?
So the value that we're bringing to let's flip it around. Actually, the problem that most of our customers have is that they're building applications, software, that needs to rely on these real-time informations that we're providing that you can see on the app. Maybe they want to show to their users how clean the electricity is in their locations, or maybe they want to build a carbon accounting software that is going to measure the carbon footprint of all of their factories across the world. Now, the biggest pain they have is that they need access to global data. They're not going to integrate with, 50 different data providers, one for each country in which they have a factory, for example. And we are the only data source where you can get through one single API, the data standardized, quality validated for every place in the world. So you just give a latitude, longitude, a place on Earth, a time point, whether it's in the past, in real time, or in the future, because now we also do forecasting. And then you'll get an answer which tells you this is how clean the electricity is. This is where it comes from. And so the business model after that is basically, we are selling access to this API. Of course, the price varies depending on what you want, if you want the forecast or not. And you get a small API token, and based on this token, you can then query the API. But that's in a nutshell the business model.
So it really helps you now that more and more companies, maybe some are already doing these climate accounts, but many will do climate accounts in the future due to the EU regulation and many other things in the sustainability agenda. So when people are supposed to do, or companies are supposed to do climate accounts, you are the ones to provide the data for the electricity. And it's much better than just doing like the average for a country, because I guess that's step one. You will just do like an average emission factor and then times it with your electricity use, and then you have at least an idea. But what you can do is to actually provide the exact CO2 emissions based on when you use your electricity.
Yeah, if we take a step back, there's really two big, let's say, growth directions that are or tailwinds that are pushing us forward. One is everything that happened, with the whole energy crisis that we have been through / are being in, with the energy independence, Russian gas being cut, and so on, is that we have an accelerated electrification, which means that you have more and more devices out there that need these real-time analytics in order to operate in a more efficient way. Think electric vehicles, think heat pumps that are getting rolled out. And all of these applications have typically a user interface, and they want to showcase to the users that they are helping the grid indeed. And so this is creating a lot of pull from our information, which is granular. And the second biggest area for growth, which is the one that you mentioned, is the one where the corporate claims are undergoing, I think, nothing short of a revolution at the moment. We used to be in a world where companies would claim zero carbon footprint, so a zero emitted carbon on their electricity usage by looking at their yearly usage of electricity, the volume of that, and then buying certificates to cover it, which would be a problem because you could, for example, say that you are 100% renewable by buying solar electricity with factories that would consume electricity during the night. That is totally possible. Or you could also cover it from certificates that will come from Iceland and be located in the Netherlands or in Denmark. That would also be possible, even though there's no physical link. And now we're going into a world where physically we need to represent what physically is going on. And that is something that the Greenhouse Gas Protocol is starting to looking at. So the Greenhouse Gas Protocol is the body that is creating the standard for how companies should report their carbon emissions.
With scope 1, 2, and 3.
Exactly, with
many
scope
of
1,
the
2, 3.
listeners might have heard of, yes.
Exactly. And so here we're actually talking about scope 2 accounting, which is everything on electricity, also heating, but right now I'm talking mostly about electricity. And we will be going in the world where, it needs to be more physically representative. So that creates a paradigm shift for companies. And in that world, they will need granular information in order to figure out how clean was the electricity I used at a particular time and at a particular place.
Can it also nudge them to actually use the energy when it's the cleanest?
I think that's one of the most exciting incentives that are new, which are that if you want to reduce your footprint, previously it was mostly about consume less electricity or buy more certificates. And because the certificates were so cheap, it was almost always buy more certificates. Whereas now, if you are constrained by physics, suddenly you'll see, building heating that will try to be more flexible in order to reduce the footprint of a building, because these certificates won't get you as far as they did before. They will get you far, but not as much as before.
That's very interesting. So it's really, it's nudging us towards a more flexible system where the users also really have a big role in when do you actually use your electricity and when do you turn on your devices. And it's one thing is to have an electric car. Another thing is when you charge it.
Absolutely. And to be frank, we wouldn't have to care about all of this if we didn't have an electricity system which was dominantly based on, or supposed to be based in the future, on intermittent energy sources such as wind and solar. If we had energy sources that could provide clean electricity every second of the year, the granularity we're providing with electricity maps would be, I wouldn't say irrelevant, but much less interesting. But if you look at the latest projections from the IEA, we are looking at something that will look like a tripling of renewables by 2030. We will be in a world where almost half of the electricity is going to come from wind and solar. And if you have half of the electricity that comes from wind and solar, you can imagine how much the carbon footprint of that electricity can vary over time. I mean, what do you do at the hours where there's no wind and no sun? Of course, you can install batteries, storage systems, import from some neighbors that might have solar and wind. But it's so much cheaper if you can actually not use the electricity when you don't have clean electricity and use it when it's available, right? And this is where all the flexible devices that are anyways going to explode, heat pumps, electric vehicles, but we're also talking data centers, by the way, and hydrogen later on. This is a huge opportunity we have, the rise of all these flexible devices on one hand, and the challenge, which is the rise of intermittent production on the other hand, well, let's orchestrate these two things together, right? And this is where flexibility is so key, and therefore why the incentives need to point us towards this granular orchestration instead of saying, let's do things on a yearly basis to accounting, because that will hide these incentives.
Maybe you can elaborate a little bit on data centers, because at first when I heard about electricity maps, I was a little bit like, so this is great and it's very fun, but is it going to yield any impact? Question mark. Because I mean, information is great, but you know, people are people, and they will do as they've always done. But maybe you can tell me otherwise.
There is this thing called, I don't know if you've come across it, called the triangle of inaction, which at the edges of the triangle, you have different actors. So you have corporations. What do they care about? Making shareholders happy, making more money in the world. You have the citizens. And then on the third leg, you have the policymakers, the governments. And what is interesting in this triangle of inaction is that everyone is pointing fingers at each other to find excuses for why not to do something. Elected politicians will maybe say, I don't have the majority, or the population would never accept that we are putting in a carbon tax. Therefore, let's not do it. Corporations will say, this is going to be too expensive for me. I need to have the right subsidies to do it. Or, consumers actually don't care about green products. Why should I try to? And so you can actually go at each edge and draw, arrows that point at the others with excuses. And we're trying to turn that around into a triangle of action. And this is why on the citizen side, we are building this app in order to help them push for the right policies, but also push for companies to make greener products. Like I want to create more awareness about the fact that electricity varies over time, because that means that citizens will go and ask Tesla and others to charge electric vehicles at the optimal time. They will go to politicians and tell them, don't fool me with some of these certificates. Please do it the right way. And the same with corporations and the same with policymakers. So we have impact examples actually on each of these three edges. Like on the citizens, we know for a fact that a lot of education has happened with the app. It's been quite popular. It's used in classrooms. It's used by, young activists as well in order to understand how the system works. On more of the governmental side, have anecdotes that I'm actually not sure I should completely tell, but anyways, which are, state leaders in Europe who've gone to, for example, the German ministers and told them, hey, have you, with electricity map in their hands and showed them the map and told them, have you seen that this, your country is actually quite dark on the map. There's a lot of coal. What are you doing about this coal? You might be talking about it given, but what about the coal here? And then on the corporation side, you mentioned the example with data centers. And one of the, I think, small actions that yields massive effects that we've done is since a couple of years now, I think it's probably 4 years with Google, we are informing the data centers about what is the optimal time and location to run. And turns out the data centers have quite some flexibility, especially in the recent years with all the AI revolution happening. It uses so much electricity to train an AI model. And that training, you honestly don't care if it happens now in 2 hours or in 9 hours.
Okay, so if you are to run an algorithm, you do have some flexibility. So it's actually very valuable to understand if I care about the environment, and they do, because it's good business to tell the world that you care about the environment. Then
Absolutely.
You can run it. Okay,
absolutely, and it goes further than that, because so think about, for example, YouTube recommendation algorithm. You don't need your recommendations to be updated in real time, so to speak, right? So that can wait a little bit. The interesting piece as well is you can shift things in space. Meaning if the wind doesn't blow in one location, then you can move that particular AI training job to somewhere else, which gives huge optimization
so
potential.
I can send the algorithm to Spain where the sun is shining?
As long as the data is there. Because if you need to move the data, then it becomes a little bit more complicated. But there are some things that are where the data is already distributed by nature. And finally, companies like Google and others are, of course, they want to tell a good story. But the bottom line is electricity will probably be cheaper at the times where they use it. And so it's also a good business case in the end.
Okay, so we have so we reach out to our audience, and we actually got some questions for you, Olivier. And one is from our data science expert, Torben Wulff, and his question is: with the complexity of electricity prices being influenced by both availability of green energy, cheap when windy, and by demand, expensive when everyone is cooking dinner, is there any way of correlating prices with emissions? And it goes on. It would be nice if we could just tell households to simply use electricity when it's cheap, and that they'll be somewhat green when making that choice. But is that even the case? So does price and being green correlate?
And that is quite a complex question, but we're going to try to unpack it a little bit. First is it depends on where. I think that's the general heuristic. And to give a simple answer, in general, in places where you have a lot of wind and solar, prices tend to be cheaper when these two are producing a lot of electricity. Now, in order to go, peel one layer of the onion and move one layer deeper, the thing is we need to understand what is actually the price we're talking about here. Because typically the price that people talk about are the wholesale price, like the spot price of electricity. But there are a lot of different prices that add up to the final cost that you will have on your electricity bill. We have the balancing market, for example, which kicks in, much closer to real time. The spot market, the wholesale price, is something that's dictated 24 hours in advance. So this is an expectation of how the system will work in the next 24 hours, which sets a price. And then there are corrections to that price as you get closer and closer to real time. The second piece is also when you're receiving electricity at home, it actually goes through a distribution network. And that distribution network has different tariffs depending on the place you live in. I know in the Copenhagen area, you have different prices depending on what hour of the day you're using it, or whether it's weekends or not. I actually don't remember if it's weekends or not, but...
Yeah, but you have the peak hours around dinner time. When you are cooking, it's quite expensive.
Right. So that is one component of the price, which changes quite a lot depending on where in the world you're located. So there's this level of complexity. And then the other question is really, it's not that much about how much the wind and the sun are, producing. It's also what is the cost of the other technologies. Because if you look at how the spot price now is typically cleared, the way it works is that you will rank from the cheapest to the most expensive, all of the power plants in the system that can produce electricity, and you will start dispatching them from the cheapest to the most expensive until you reach the level where everyone has electricity at home. That's basically how it works. So the cheapest electricity is always, or very often, wind and solar, because they have almost zero marginal cost. When the wind blows, you don't need to do anything. It's going to give you electricity. Then you add the other stuff on top. The problem is at some point you start to add some peaking plants, as we call them. It could be gas, it could be coal, it could be something else. And they have a carbon tax on top. And so depending on what this carbon tax actually points at and what the price of gas and the price of coal is, the price of electricity can be skewed in different directions. And so you had, for example, examples where when the gas prices exploded, gas is better than coal in terms of emissions, but when the gas price exploded, even with the carbon tax was not enough to rank things in the proper order, which meant that at some points in time, you had coal-based production, which yielded an electricity price lower, emissions higher than other times where you had gas in the system, because when you had gas, it was kind of like last resort situation. Prices are very high, but emissions would be a bit lower. So all of this to say there's quite a lot of complexity, but the more we move towards a direction where we have more wind, more solar, and the more we move into a direction where you have a stronger carbon tax, then the more this correlation will be stronger. And I believe that, the world will inevitably go in a direction where price and emissions will be highly correlated.
So you mentioned carbon tax, and you said when we have a stronger carbon tax, so how strong does it have to be or need to be?
Oh, that's, there's lots of papers and academics that are debating over that. But maybe it's worth clarifying what carbon tax I'm referring to here. Because in the European system, we have something called the ETS, which ends up being a cap and trade system, as we call it. So meaning we issue a certain amount of certificates and limited pool of them all companies that are emitting carbon, they need to buy one of these certificates. And when there's no certificates left, then of course everyone will fight over the last certificates, which are allowances to emit. And so the price of these will rise. So that means that the carbon tax I'm referring to and its price is constrained by, one, the availability of these certificates. And so the European Union, is setting some rules on how quickly they want to make this pool smaller, but also on how people actually want to emit. The more people want to emit, the more the price goes up mechanically. Now, the real question is, how far do we need to go before it gets to a level where it really decarbonizes? And the problem is, it's not a binary answer. It's not like you get to a level and then, done deal, you're done. But we have seen already its effectiveness in motivating, let's say, incentivizing the transition from coal to gas, where coal emits more, gas emits less. And so the final cost of electricity generated by gas, it basically helps when you have this carbon tax because it makes coal more expensive artificially, you could say, thanks to the tax.
Okay, so just to recap a little, so the answer to the question from Torben is that unfortunately it's not black or white, but you expect that in the future it actually will be. We are, getting closer and closer to being able to say, yes, when it's cheap, it's also the greenest. And then just to understand this carbon tax, it's effectively just a market where you have these certificates and we can, slice the pool of certificates and then, the tax will go up. But we could also just see a shift in how we use our money. So we just, spend more money on these carbon taxes, and then we still have the same emissions. Was that a fair
Absolutely.
recap?
No, that's a fair recap. But an anecdote which is worth mentioning, though, is that we are witnessing in Denmark pretty strong correlations at particular times. You have negative prices on the spot market, quite often. That indicates the fact that there's so much wind in Denmark, we can't get rid of it, and therefore we will pay, consumers to help us get rid of it. And this is where you could say, I think it's a good indicator what's coming in the future, because we know there's going to be more of these events where we have too much wind. On the other hand, we don't right now have enough flexibility. I mean, I would love to get paid at home, to start cooking and so on. Right now, it's not the case. Even though you have negative prices, most often the negative prices don't reach us because, as I mentioned, we have all these distribution tariffs, taxes on top. And so the price is negative on the markets. It's not negative at my home, right? I don't have my electricity provider sending me a check at the end of the month, unfortunately.
But could we maybe elaborate a bit on these different devices that can be part of the flexible energy system of the future? So now I'm saying energy, but we of course, as you might have noticed throughout this episode, that we're specifically talking about the electricity, but of course the energy system as a whole also includes the heat, as you also just briefly mentioned, and then our transportation sector. But that is being more and more electrified. But zooming in on the electrical devices that can contribute to this more flexible system. Maybe Olivier, you can mention what do you see? Now I mentioned the electrical vehicles. That's in my view maybe one of the big changes here. But what else do we have in the system? Do you believe in the batteries, for example?
So I think we have to differentiate a little bit what timescales we're looking at, because it depends a little bit on how quickly we roll out things. But if we think about things that use a lot of electricity and have a lot of flexibility, I mean, then yes, you have batteries, but it depends a little bit also on what batteries we're mentioning, because there's batteries inside the electric mobility in general. It's actually not only electric cars, right? It's also electric buses. It could be like shipping. It could be a lot of different things. We've been thinking about factories as well. There's a lot of factories that are using a lot of electricity, and do they have some flexibility or not? I mean, you're not going to ask people to come and work in the factories during the night. On the other hand, if it's mostly driven by robots and so on, then why not modulate up and down, right? Data centers, we talked a little bit about. There's an extension of that, which is the whole infrastructure around digital communication. I'm thinking more about all the different switches and all the electricity used to transfer information, not just to run the CPUs, but actually to transfer the information. We're working, for example, with Cisco, and these are things that I know are going to be explored in the future. Heating is a big one as well, and then grid level storage. But again, if you look on electricity maps, we do have grid level storage There are some countries where you can see battery storage. I think in Australia, there's this infamous big Tesla battery, which has been installed, and you can see it on electricity map. It's just a tiny, bit compared to the whole electricity system. So we're still in extremely early days when it comes to battery storage. And then later on, there's the whole promise of electrolyzing hydrogen for storage, right? And that's also, let's say, before 2040, 2050, I think it's going to be difficult to see anything. Right?
Known as the power to X.
Yes, and I think power to X is a little bit wider because it basically just says take power and turn it into X anything. So it's also e-fuels and so on and so forth. And here we're talking specifically about storage, I guess. But.
So this might be a dumb example, or question. But what about supermarkets and their refrigeration systems? So basically, their freezers. I don't know if this will damage the meat. I know we're not supposed to eat meat, but let's say the frozen vegetables. So I don't know whether it will damage that. But I mean, imagine that they could, freeze it down to, I don't know, minus 50 or minus 100, and then it will actually stay frozen for a day.
That makes a lot of sense. So you can, I tend to think about heating or cooling systems as energy storage in a sense, right? Yeah. You're just storing different energy. What you're doing is taking electrical energy and then you're cooling something down. And once you've cooled it down, then it has a certain inertia. It can stay cool. It will, of course, warm up, but it can stay cool for a certain period of time. And that means that you don't have to use electricity in the upcoming hours. And so in a sense, what you've done here, instead of cooling a little bit every hour, you can cool a lot in 1 hour and then you store that electricity. Of course, you're going to have losses. It's always better to heat, or cool a little bit in many chunks instead of just cooling it down a lot and then letting it cool afterwards, because you need to insulate it quite well.
But I mean, we're talking about this because not so much the demand might be very stable or rather stable, but it's the supply that's making that's giving us this hardship. So I guess that's the only reason why we're talking about, okay, so when can we use the electricity when it's actually there?
Even though it's not the most efficient way, as you
say. Exactly, yeah.
It would be better to, if we had the same amount of CO2 per kilowatt hour, it would be better to use just a little bit of the time doing the time. But since the electricity is fluctuating, then it's better to use maybe a bit more, even though it's not that efficient, and then have a big of loss.
Yeah, absolutely. And the thing is, you want to, you're offsetting some of the loss by the reduction in carbon footprint. And in the end, your footprint, if you have all things equal, a little bit more losses, your footprint goes up. But if you're actually acting more on the supply side and saying, I will consume at a different time, if the carbon intensity goes down by a factor of 4, you don't care about having, 10% losses on a factor of 4. That's still like a huge improvement you're having. And so we're having, as you mentioned, like this fluctuating supply. On the other hand, a pretty consistent demand for cooling or heat. And that is something that we can alleviate, especially as the cooling needs, you have inertia in the system, which means that if you're cooling down in a supermarket, the fridge, for example, you have a little bit of time before it goes back to the point where you need to cool down again, especially if you apply even more cooling, as long as you don't damage the goods, right? And that creates a lot of flexibility. And I know from the experiments that we've been running, you can see 10 to 15% savings in carbon footprint if you go from whether it's a heating or a cooling system, if you go from a traditional, naive cycle where you just do it every hour or every half an hour to something where you have an algorithm that controls when is the optimal time to use electricity, as long as I stay within comfort bounds in terms of temperature, as long as my goods are not damaged. You can build a model for that. It's not too complicated. And you can have 10, 15% savings.
I also just realized that you might need to give people special gloves for when, if you're the first one to pick up the frozen vegetables that are now minus 100, then I don't know, you might get, it's not called sunburn, but ice burned.
Maybe we don't want to go to such extremes, right?
No.
I remember the study that we did, and we have a blog post about that. The temperatures weren't changing drastically. What I mean by that is by changing the timing and by going a little bit over or under, but we're talking half a degree Celsius over and under, not like, 5 or 10, then you can actually save quite a lot.
Yeah.
Is it time to hear about Olivier?
Yeah. So now we talked a bit about the travel of electricity maps and also when you started it. But Olivier, I was wondering, what was the steps you did before you started your electricity maps travel?
So we can start at the very early stages. I'm half French and half Danish. So I guess my education was always a little bit taking a little bit best of both worlds. I'm born and raised in France, but then did university studies in Denmark, where I studied mathematics and statistics. Worked a lot on wind power forecasting as well back in the days at DTU. Was in France working on more general engineering, but also some entrepreneurship. And I've always been a little bit fascinated by the differences between two systems, where the Danish one is very, let's say, hands-on, experimental. You directly get an intuitional feeling about things. And research, honestly, in Denmark is amazing. You work directly with direct impact. As a graduate student, I was allowed to, tweak some of these algorithms that we talked about for supermarkets. On the other hand, in the French system, we'd have a whiteboard, a lot of theoretical knowledge, not that much application. But on the other hand, it is very, very handy when you get to the application stage that you have sort of the theoretical fundamentals. And I think this followed a little bit onto my steps afterwards. I was at IBM Research, where I did a lot of grid modeling in order to see, can we build a smart grid where we can orchestrate the system between this fluctuating demand and this rather stable consumption or demand? Worked on some systems that were trying to generate electricity prices in such a way that we would incentivize customers to use electricity when it was the cleanest. So instead of letting the market decide what the price was, it was an algorithm deciding what the price was, which was an interesting
so that would actually be a fix to Torben's question.
You could look at it that way. It just turns out that it's almost like economists versus engineers. What's the optimal way to form a price in a society to decarbonize it the fastest? Is it to put an infinite carbon tax and let the market play out, or is it to put an algorithm that's going to predict the future and create the optimal price setting? I remember we had a lot of debates on that. So I took the engineering route at that time, and then I worked as well at Google, where I was doing a little bit of energy, but a lot of different things, actually, like orchestrating what they call cross-product abuse. So looking at spam systems and how people were abusing the different systems at Google, sort of Gmail and so on, which was a little bit of a departure. And then I was at the AI startup in France, where we were building a little bit the equivalent of Siri. It's like this intelligent assistant on the device, completely private by design, like without a server. And that was a lot of inspiration for some of the things we did in the very early days of electricity maps, where we ended up building a carbon accounting app, which was fully automated, which was one of the experiments that we did back then before we decided to focus 100% on electricity maps.
And electricity maps started as a startup. Now, that was also how I introduced you in the beginning. And before we started recording, you said that you actually still consider yourself as a startup, but you have actually been in that company for 7 years?
Yes, that's correct.
So can you just elaborate a bit about, like, it was a startup, but it's still a startup, but you were like 20 employees?
Yes. I guess it depends what you call a startup in the end. I think what I characterize a startup being is a rather smaller group of people that are always trying to find the most pragmatic and fast answer to a solution. And so I think maybe we are now in a stage where the company is a little bit more experience and exposure after 7 years. On the other hand, I hope to think that we still have a little bit of the scrappiness and the sort of, let's just get things done and find a quick solution to what we do, which still characterizes us as a startup.
I really like that. I'm not sure I like the flip side of it or the consequence of it, that, large companies are just a big group of people trying to find the
most complicated ways.
Exactly.
Yeah, I think you should strive to stay with this like startup spirit as long as possible. And it's not a secret also that I think a lot of larger companies have tried to inspire themselves of this of what happens when you have the scalability that a lot of startups have, right?
But can you tell us a little bit about, why the energy sector and why electricity? It seems like you told us you worked for IBM, you worked for Google, you worked for a startup in France. You could have done anything. So why this sector? Why this area?
Yeah, what happened in 2016, which led to the creation of Electricity Maps, was that I quit my job at this French startup where I spent 2 years, and I shall say as an arrogant Frenchman as I am, I thought I knew everything about starting a company. I was like, sure, I'm going to start a company. I'll figure out what it is about. And then I read the IPCC reports. I had a couple of key questions, sort of almost academic, that I wanted to answer, such as, can we power the world with 100% renewable? How can we at scale decarbonize society? How big is the climate change issue? Which led to me actually writing down this pragmatic guide to climate change that you can still read on our website, which was a little bit a way to share the discoveries that I had with fellow tech entrepreneurs, because everyone at the time were speaking a little bit like today, to be honest, about how hyped AI is and how it's going to save the world and it's the solution to the climate crisis as well. And I think we've gotten a little bit clever nowadays, but back then, my conclusions were basically, if you look at greenhouse gas emissions, most of them come from the energy sector. If you look at the energy sector, 80%, 85%, depending on exactly how you calculate it, of that energy is fossil-based and is causing CO2 emissions. The thing is, if you look at CO2, again, playing, economists versus physicists, the economists will probably say value added in the world can be measured using GDP. I'm more of the, let's say, opinion that if you want to measure value in the world, if you look at energy, that's a better measure of it, because every time that you are creating tangible value, even if you look at AI and data centers, you are in the end consuming electricity. If you transport something, if you flip bits on a computer, if you're cooling or heating something down, if you're molding, cutting, whatever, if you want to make steel, that's all energy.
That is at least the case up until now, and actually still the case. And I guess we've also talked, at least on this podcast, with Rune Bostrup about the fact that we haven't managed to detach value creation from emissions.
And to be frank, it's a question I have tried to find a, let's say, data-driven answer to. And it's extremely difficult because the problem is in the economic system, the way we're measuring GDP as well includes inflation of assets, which means if my apartment doubles of value, then suddenly, that extra apartment is counted in the GDP of a country. What's the actual value delivered? You could argue it's none, right? So it's very difficult from a physical perspective to say, can we actually uncouple emissions from growth? And I think the best indicator we can actually look at, it's not perfect, and it is to look at emissions from the energy system. And if we can make sure that for every kilowatt hour of energy used by humanity, the emissions associated go down, then that's a meaningful indicator. But when you have 80% that comes from fossil fuels, and if you think that energy is the way we measure value, you're looking at a problem that, is stated in the following way, which is we need to get that to zero by 2050 to get to, the 1.52 degrees. It's 80% of our energy usage we need to get to change. So it's 80% of the way we are creating value in the world, like not a small thing. And when you look at the solution side, electricity is the most promising vector where we can decarbonize because we know how to make clean electricity, hydro, nuclear, renewables, geothermal. Making clean energy, which is not electricity, that's a little bit more of a headache, right? You can do it, but it's very use case specific and so on. And that's why for me, electricity is at the cornerstone of everything. And when we go into electricity, there's two things that we need to work on. One thing is electrify, and the other thing is ensure that we have a clean electricity system. And we are working on the clean electricity system part. There's a lot of other people working on the electrification side. So this is why electricity.
Oh, well, it makes perfect good sense, and it's thank you for the explanation. And it's almost like when I hear you explain why, it's like where do I sign up? It's fantastic.
Olivier, I would like to ask you, what's next? How do you imagine the future? If you should see in 10 years, in 30 years, maybe only in 3 years, how would our energy system of the future be sustainable? Or what do you think it takes to get there?
I think one of the biggest components is going to be flexibility. I think it's quite uncontroversial to say that wind and solar will probably be one of the key levers to decarbonize. And I'm saying that while knowing that we typically end up in these like nuclear versus renewable debates, especially on social media. We're getting quite attacked sometimes because nuclear is a low carbon technology. But in every projections that you see out there, they basically say that even if we went as fast as we wanted with nuclear, we will get faster if we also add wind and solar on top. So that means that regardless of the nuclear versus renewable question, we know that the electricity system of the future will rely on intermittent technologies, whether you want it or not. The real question is what politically is going to be acceptable. And, there's some countries that will not want nuclear, some countries that will want it. But on the large scale of things, we will have something which is more weather dependent. And this weather dependency means flexibility on the other side of the spectrum, right? It will need storage, it will need flexible consumption. But when we also look on the other side, as I mentioned before, this explosion of flexible devices, that's just too good of an opportunity not to use, right? And so I think like what we see as being next for us is to see how quickly we can accelerate having all these billions of devices be helpful now that they're going to be installed anyways. Let's make them intelligent so they can help the grid, right? And in order to get there, we need to get the incentives right. Hence, we're talking to policymakers, making sure that the claims are physically meaningful and that we're talking about electricity using at a particular point in time. So it creates the incentive. The other thing we're going to look at is how to get more of this cost component as part of our offering, because we know that imagine you're a heat pump manufacturer and you want to install new capabilities where you want to have this flexibility built in. If you can have a global offer where you understand what the cost of it is, the CO2 emissions are, and if you can tell to your end consumer, hey, I'm actually selling you a product here that's also going to reduce your electricity bill. And it's hard to say no at the end of the day, right? So this is really where we're going. It's enabling all of these connected devices to use electricity at the optimal time.
And that's maybe something we already seen started. At least I have a dishwasher at home. It's not intelligent because it doesn't start by itself, but I can press a button and then tell it to start in an hour or actually it has the full, I think I had up to 24 hours. So I can use my app and go for myself and check, it's going to be cheaper and greener in 4 hours. So I will start it maybe in the night or in the middle of the day. Today I started at 12 o'clock because that was the cheapest time today. So we have already seen this transition a bit at least, but I'm still lacking the full intelligence that it would start by itself. I haven't seen, at least not as a consumer, I haven't seen that many devices doing that. I don't know, maybe there will be some intelligent chargers for electrical vehicles already.
So it depends a little bit on the maturity of the different industries. We are working, for example, with, Monta, Clever, Spie in Denmark, and they are already experimenting with smart charging solutions based on our data. You even have I remember the Monta app has this pretty neat visualization where you can select between what I care about is amount of renewables, carbon emissions, or cost savings, and you can say how much you're willing to optimize or sacrifice one if you want the other. That's one thing. The other thing is you mentioned dishwashers, and we are working now with Samsung. And so in the Samsung Smart Things app, you can now see the carbon footprint of your devices. And very quickly, we're going to be able to go to the next step after, which is to say, let's make sure that this dishwasher, which already has the capability to schedule at a different time, it just needs to listen to a signal.
Yeah.
The question is, how do you get them to connect together and so on and so forth? And how do we ensure that your electricity bill doesn't go up because someone screwed up the prediction? These are things that we need to get right, of course, but this is a problem that will be solved very quickly.
But that's something you think is in the near-term future, something that we might see?
Absolutely. We're doing everything we can to push these companies to move forward. And again, going back to this triangle of action, we need to make sure that the policy making is the right place. So, a company like Samsung, for example, is incentivized to do the right thing. We need to create the audience. Like, we want more people like you to yell at them, so to speak, and tell them, hey guys, I would actually buy this if you could manufacture it. And then we're going to companies like Samsung and tell them, look, all these people are looking at electricity maps to schedule the dishwashers. I mean, shouldn't you guys, embed it in your app? So we believe it's going to happen quite soon. But it's always a little bit disappointing from an entrepreneur's perspective that things are not moving as quickly as we'd want them to.
I think with that, Olivier, thank you so much for sharing your story and telling us about electricity maps. And to everyone who's listening, do yourself a favor, check out the webpage. So it's electricitymaps.com/maps, right?
Yeah.
And last but not least, so what would you call a green sofa in French?
Green sofa, you could say le canapé vert.
Le canapé vert. You heard it here the first time.
Nice. And good accent, by the way.
Merci beaucoup.
Yeah. And thank you for listening to the green sofa today.
Thank you for listening to Le Canapé Vert.